This is the 2018 question 5 U-values. A house is built in the 1970s, has an uninsulated solid concrete ground floor as shown with the sand cement fine screed finish. Calculate the U-value of the uninsulated concrete ground floor given the following data. So part A here, what we're trying to figure out is how much resistance the floor is putting up to stop heat going down through it, and then we can turn that into our U-value. So we're given sand, the screed, we're given the concrete floor slab, radon barrier, sand blinding, hardcore and subsoil. We're going to input all those into our table. We've got our thicknesses for each, but they need to be converted to meters. So the first thing we're going to have to do is 50 millimeters divided by 1000, 100 millimeters divided by 1000, 0.25 millimeters divided by 1000, and so on. Okay, so as normal, we basically have a template for these questions. As soon as you get the question, your three formulas go up across the top. U value equals 1 over the total resistance. Conductivity equals 1 over resistivity, small r. And then resistance, capital R, equals thickness divided by conductivity. We said our table is the same all the time. So material, thickness, resistivity, conductivity, resistance. And then we start to input the values. So our floor screed had a thickness, or has a thickness of 0.05. That was 50 millimeters divided by 1000. Floor slab was 100 millimeters thick divided by 1000, so 100 divided by 1000, 0.1. Radon is very, very thin. It was only a quarter of a millimeter to begin with, so it's 0.00025 when you divide that by 1000. Sand blinding 0.04, hardcore 0.2, and subsoil 0.3. So that is our values for the thicknesses put in to begin with. We've this table accounted for. Now we'll move down to the next table and we're going to put in all our thermal data. Resistance of the internal top surface is 0.104. I'm going to have to write that one in. I haven't put in the top surface yet. So in here I'll write top surface, and it was a resistance measurement 0.104. I'll go and find the thermal data values for each of these now and drop them into the correct place. So for example, the screed, I need the thermal data for the screed. Its resistivity is 0.710. So resistivity is 0.710. Floor slab. The floor slab has a conductivity of 1.280. Floor slab, conductivity 1.280. And we fill in all the other measurements as we've done those first two. We need a resistance measurement for each material. My resistance is thickness divided by conductivity. So I have all of the conductivities given to me apart from one. I need to find one conductivity. It's for the screed. Conductivity is 1 divided by resistivity. So 1 divided by my resistivity measurement. 1 divided by 0.170 will give me my conductivity measurement. So 1 divided by 0.710 gave me a conductivity of 1.408. Now I need to work out my resistances. Each resistance, we said, is thickness divided by conductivity. So my first one is going to be 0.05 divided by 1.4. So 0.05 divided by 1.408 equals 0.0355. Second one, 0.1 divided by 1.280 equals 0.078. All the rest are going to be the same. So radon 0.00025 divided by 0.250, and so on. Alright, so worked out each of the resistance values, and then we add each one up. So add those all up to get the total of 0.8041. We've got our U value calculation down here. U value equals 1 over the total resistance. So 1 divided by 0.8041, and we work that out. Equals 1.2436. The value is important. Watts per meter squared per degree Celsius. And that's part A worked out.